Here you go. And some of this is very basic, I know that, but I don't want to assume you remember all of this stuff. So the first couple of things I'm just going to fly through, honestly. So types of angles, you've got your acute, right? It usually looks like that. No, you don't need glasses. I just need to focus. There you go. And it's less than 90, right? 90 degree is kind of like our, let's go here to the right angle. That's our standard. It's a 90-degree angle, right? There's 90 degrees of separation between the two arms. So that's a 90-degree angle. So that's kind of like our standard. Anything less than 90 is acute. Anything greater than 90. So imagine this would be your vertical. That's a 90, but this is greater than 90, right? So an angle that's greater than 90, greater than, not 90. And I know you remember a lot of this, so bear with me. Greater than 90, 90, and then you've got your straight angle. So you got to imagine there's a dot, and if you were to go to either side of that dot, and they're perfectly aligned, that would be 180 degrees. Okay, so that's a 180-degree angle. A reflex. Anybody remember what a reflex? Reflex is actually bigger than 180. So imagine this is your 180 mark right here. This is even bigger than that. Okay, so it's greater than 180 degrees. So there are your types of angles reviewed. The following properties are always true. Okay, these are always true. But these cannot, I'm already foreshadowing here. You cannot use these to justify whether or not lines are parallel. Okay, you cannot use this to demonstrate whether or not lines are parallel. But in and of themselves, these properties are always true. So complementary angles, think of it this way. It is right to complement someone. It is right, that's a 90 degree, right? It's the right to complement. So complementary angles, angles whose sum is 90 degrees. So I'm going to use my pink highlighter in this case to highlight my right angle. Right? That would be a right angle formed right there between those pink lines. So anything in between should, like all the angles that are in between these two, they add up to 90. Okay, so angle Y you would find by just going 90 minus 20, right? If you take away the 20, you're left with Y. And that's 70 degrees. Boom. That should be pretty straightforward. Let's go over here. Supplementary angles. Maybe I'll use orange for that. Supplementary. Angles whose sum is 180. Okay. The shortcut when we refer to this will be straight angle is equal to 180. Like if you ever want to use that property, I'm just going to say that. Okay. Or supplementary, it's up to you. They're interchangeable. Okay. So if this had been 30 degrees, okay, you should realize, right, where they meet, you should realize that there's a straight angle at the bottom of this thing. Okay. You can also highlight 180 maybe, right? Like just the fact that those orange lines at this intersection here, you can put a dot there, right? There's basically two arms here. They form a 180, and then something has been added to basically cut the 180. So then this angle over here, if we want to call this angle X, right? Angle X would simply be found by going 180 minus 30, and so X is 150 degrees, right? So that's how you do that. And it gets it can be, there can be many angles along that straight angle, okay? So down here, for example, you should realize that there's a straight angle right here along the bottom. Okay? So I was like, hey, that means that any angles that are formed between add up to 180. So angle X in this case would be 180 minus 31 minus 24. Okay, and in this case, it gives us 125 degrees. And there's your angle. So I could give you many, many examples, but this will suffice for now. Let's keep going to page 3. The reason why there's some blanks is sometimes I add stuff, but I think we're good here. All right, the next one is vertically opposite angles are congruent. Okay, vertically opposite angles are congruent, and you can, the shortcut would be vertically opposite angles are congruent. That's what something like that. If you actually want to write out vertically opposite, that's fine with me. Let me just adjust my booklet. It's a bit stubborn yet. One corner wants to lift up on me. I'm going to move everything a bit here. Okay, so vertically opposite angles in a nutshell, if two lines meet, this is the most basic example, you would say that this angle over here, which we would call X, is vertically opposite to this angle Y. Okay, and so we would say angle X is the same thing as angle Y. They're equal to each other. Why? Because vertically opposite angles are congruent always. They're going to be the same. Maybe I will use GeoGebra later on to show you that. Okay. So there's also two vertically opposite angles right here, but I'm just going to focus on that one there, on that one pair for now. So let's go over here. How would that property help you? Okay, so I'm going to use maybe this green highlighter. You should realize, like, okay, these two lines here, right, they form this angle here, and that angle is vertically opposite to this one over here. Okay, these two are formed by the same two lines. So angle Y, let's make sure we use our space wisely here. Angle Y is simply 29 degrees. There's no calculation required. You should just realize, hey, they're vertically opposite. They share the two sides that created them, okay? And then 35, for example, 35 is vertically opposite to X. So I'm going to use a different color there, of course. Let's say pink. Whatever you have, it doesn't matter. And this one here is vertically opposite to that one. This is a very powerful tool that you can use later on to solve for missing angles. Right, so this is 35 degrees. X is 35. How would you find Z? We just talked about that one. Did I use orange for straight angle on the previous page? I did use orange for a straight angle. And whether you see it or not, I will. You can do it in many different ways, but I will focus on this one right here. This is a straight angle right here, so any angles that are in between, right, should add up to 180 degrees. So that's how I'm going to find Z there. Angle Z is 180. So I'm already combining what I learned in the previous on the previous page, or I was reminded of. You already knew that. Okay, that's a 116, and you can just say straight angle is equal to 180. And you might wonder, why do you do that? Why do you tell me? Why do you add this written part? Because I'm going to start asking you to do that for everything we do. It's like, how did you come up with this? There's the work, and this is the justification or the explanation as to how you did that. And I would normally put vertically opposite next to these, but that is the whole section is about vertically opposite angles. Okay. Did I talk about congruent? That's a symbol for congruency. I may not have mentioned. So congruent is just an equal sign with a third wave, right? A third little, you're probably thinking COVID, another wave, right? And no, this is just an equal sign with a, that means congruent. Congruent just means equal. Okay, when sides are equal, angles are equal, we call them congruent. It's another fancy way of saying they're the same. Okay, right. Sum of interior angles of a triangle is equal to. What do all angles in a triangle always add up to? 180 degrees. Right? Okay, that should be review. That should be review, and the shortcut is this: sum of triangle is equal to 180 degrees. And you're like, why? What's the shortcut all about, Mr. Dirksen? Because I later on, I don't want you to write out because the sum of angles in a triangle is equal to 180 degrees, right? It's too tedious, it's time consuming. So if you just give me that, I'm fine with that. Okay. Sum of interior angles of a quadrilateral is equal to four-sided. A square has 4 90-degree angles, right? 4 times 9, that's 360. 4 times 90, 360. So for a quadrilateral, quad, think of 4, right? 4-sided. I'll write that down. 4-sided. 4-sided shape. Triangle, 3-sided, right? Penta, that's 5-sided. So quad is 4. So I will just say sum of that is equal to 360 if you ever want to use that. Okay. So I wish I had added all of these on one page. So everything we just learned, this sum of triangles 180, sum of quadrilateral is 360, vertically opposite angles, straight angles, complementary angles, all of those properties you can use whenever you want, whenever you see it. Okay, so do I want to add an example of this? Not yet. I'm just going to leave that for now. Okay, when are these? I'll just say this. Why is this important? If you know two angles, right, comma, you can find a third. Right? With this property, you can find the third angle if you have to. You just subtract them from 180. On this one, it'd be if you know three angles, you can find the fourth. That's why I'm giving you that. It's going to help you find missing angles because soon you're going to have to be the detective. You're going to have to find the mystery angles. Okay. All right, let's keep going. 3-letter angle notation. I just need to address the 3-letter angle notation. So sometimes you will see me put smaller lowercase angles inside a shape. So let me just be clear, right? I use lowercase inside. That is okay. You're probably used to capital letters, right? Capital letters on the outside, that's also okay. You're probably used to theta, beta, gamma, those letters, those are really letters. And I'm just not using them. I use X and Y, but theta could show up, okay? So 3-letter notation, why is that important? I need you to be able to read that, okay? So let's say we call this one angle X, and this one on the other side is angle Y. So that would be pretty simple to refer to, hey, angle X, you know exactly where it is. But you need to be able to write it like this, because angle D is it's not enough to just say angle D, because angle D has 2 angles involved. So if you want to isolate just this side right here, you need to say angle ADB, right? So this would be angle ADB, or you just reverse it. See how I wrote this down, ADB? You can go backwards, BDA, right? It's the same angle. If you started up here, BDA, it's as if you were to connect those 3 points, and then that angle that you get is the resulting angle. So this is angle X, okay? This is the 3-letter notation to refer to angle X. If you wanted to refer to angle Y instead, let's go angle Y like this, and I'm just going to give you 2 options here. You could go BDC, so that's one version of it, or you could go CDB. You basically read this backwards. Angle CDB. Okay, I'm going to give you 2 more. I'm going to call this Z, and I'm going to call this angle M. I want you to give me the 3-letter notation for Z and the 3-letter notation for angle M, okay? And I'm just going to do my attendance real quick. Okay, so angle M, you could say DBC, or you could say, just read this backwards, CBD. In fact, if you had either one of those, I'd be fine with that. And then we go over to this side for angle Z, you would go ABD, or just read this backwards, DBA, right? DBA. If you got that, you're doing okay. I'm going to tell you something though, because I personally, I don't like working with 3-letter notations. I really don't like them. It confuses me, right? Like I'm like, where was this angle again? It doesn't stand out to me. So I give you full permission. So let's say I'm like, hey, solve for angle ABD, right? And you're like, where is that? ABD, okay, it's this one. You can call it Z if you want. You can actually come into the diagram and just say, hey, this angle that you want me to solve, Mr. Dirksen, I'm going to call that something else, because I don't like to stick with 3-letter notation. And then you just go with that single letter and solve whatever you need to do, okay? So full permission to do that. There's nothing wrong with it. It's actually a legitimate, you're just renaming it, okay? Let's keep going. What did I want to do here? Oh yeah, I wanted you to find the following. So I'm just gonna give you a whole bunch of angles. Just write them down. Oof, sorry, I have to redo that. That's not it's like I'm gonna ask you to go find, should have done that right away, to go find these angles, put a number in for those, and then on the other side AFH and AKH and angle KAF. Some of them are straightforward. Some of them you can just tell what they are. You can just write down the numbers. Some of them you might have to use one of the properties I just taught you, I just showed you up on this page. to find them. So I would say first step is go find what you can find, get those numbers out, and then find the ones that aren't so obvious at first sight. Okay, so try that, and I will. All right, let's see how you do it. GKC. So that GKC is right here. It's this one right here. I don't know if you. So I don't know that this yet. So I'm going to wait for now. Right. BAE. BAE is this one right here. That's 83 degrees. LFD. LFD, that's this one right here, 103. KHF. KHF, that's 77. Okay. Then I go over here, AFH. AFH, so this one here. I don't know that one just yet. I'm gonna. AFH is right here. To be continued. AKH. So AKH. I don't know that one either. So for now, I'm just gonna say. I'm just gonna leave that there. And then KAF. KAF. I don't know that one either. Running out of highlighters. KAF. KAF. It's right here. Okay. So this is what I mean with you're gonna have to start finding mystery angles. Okay. So it doesn't matter which one you want to start with. Maybe I'll start with this one here, the green one. What property that I've just learned about could I use here? And I would argue the supplementary or straight angle is this straight angle right there. Okay, so I can basically just go 180 minus 97. It'll give me that green one there. So I'm going to actually show that work. 180 minus 97, and that's 83 degrees. Okay, and I'll just say straight angle. That's my justification there. I'm going to go to AFH, this one, the pink one. What could I use to figure this one out? What are these two here? I just learned about that, right? They share these two sides, vertically opposite. So this is actually 103 degrees. And you can just say vertically opposite angles are congruent. Boom. Oh, it's cutting off, right? So that's good. So this 103, you can actually write that in, right? What else? The orange one here. I could also use vertically opposite because this one, I just figured out that this is 83. I'm going to write that in as well. So these are vertically opposite here. So the orange one is also 83 degrees. Vertically opposite angles are congruent. That's my reasoning there. KAF, this one here, I'm also going to use vertically opposite because it's just the easiest one. Okay, 83 degrees, vertically opposite angles. Oh, I just use vertically opposite angles every time, Mr. Dirksen? Well, if it's possible, yes. If you rather use the straight angle, for example, here, guys, this is also a straight angle right here. So you could have gone 180 minus 97 to get this one. You would have still ended up with 83. So it's all connected, right? There shouldn't be any contradiction on how you do that. Let's keep going. So here is this is a classic. You're going to see a lot of these down the road. This is on page 4. Okay. So there's going to be the actual angle measure that I asked for, and you have to show some work and justify how you got there. Okay. Sometimes there's no work needed, as in the vertically opposite angles scenario. Okay, so let's see what we can do here. I need you to tell me where you start, because not everybody starts in the same way. And it's a nightmare for me to mark if you don't tell me where you started, because if you make a mistake, you could lose marks at first, but then if I follow your train of thought, then I still give you marks for the rest. Okay. So what would be the easiest to start with here? You know what I see? And I've done this many times already, but I'm scanning everything. I see these two being vertically opposite. Do you see that? Now, hopefully, these are, so I'm going to start with Z. Okay, I'm going to say this is my first angle right here. I'm going to start with that. I'm going to call this 85 degrees. Why is that? Vertically, if you can write a little, vertically opposite angles are congruent. Bingo, that's done. Is there another one we can do? Look carefully. I'm going to choose to do M. Why is that? I see a straight line, a straight angle right here. You're like, that's slanted, Mr. Dixon. It's not straight. It is along this line. That's a 180-degree line. Okay, so that's a straight angle right there. So to find M, that's my second one that I'm going to tackle. I'm first going to do some work here. I'm going to go 180 minus 45, and that leaves me with 135 degrees. And I'll say that, right? Straight angle is equal to 180, something like that. And so you put the 135 in here. Now you got that taken care of, right? So we did this one, we got rid of that one, and now Y, let's do that one next. Y. So do you see another straight angle there? You see this one? There are two angles along this straight line here. So I will highlight that again. Okay. You want to do this? I think this would be, I'm trying to help you here. I don't need this, but I don't know if you want to do one of these and then one of these, all right? Like put like a little hat there to show like, oh, okay, that's my straight line there, my straight angle. So for Y, I do the same thing, 180 minus 85, and that leaves me with a 95 degrees, and I used straight angle is equal to 180 again. Okay, so sometimes work needed, sometimes it's just vertically opposite, it's just boom, you just state it. So you just put the 95 in here. Check, right? So 3 out of the 4 are taken care of. One second here. Was I careful with this one? Hold on. Yeah, okay, it works out. Phew. The next one I'm going to tackle is this one. How would you do that one? Is there a brave volunteer here? How would you find the top there? Angle X. Jessica? Sum of a triangle? Yeah. You see a triangle? I see at least two, right? There's a triangle here, or there's this big triangle here. I checked, and it should be regardless of which triangle you use, you still get the same answer. Unless I made a mistake, and so these ones I have to be very careful when I make them, right? That everything adds up, or else it's not correct. So let's do 180 minus 60 minus 70, right? So yeah, your teachers may have done minus 60 plus 70 in brackets. It's the same thing, right? Just subtract the two angles that you have, and you're left with 50. and I will say sum of triangle is equal to 180 degrees. So there's your 50-degree angle. Would this be too much if I just watch it, see if it helps you? If it doesn't, don't worry about it. But I'm going to go on the inside here. Right, and just say, and maybe say that. And maybe every time I use straight angle, I will go orange over it. Okay, that way it sticks out. But if you had used the triangle here, it should be the same, regardless of which triangle you use, because it's all connected, right? Everything is connected. Okay, so this is a classic show the angle and how you got there. This would be the fourth one we solved, right? So I went 1, 2, 3, 4. And it's kind of like choose your own adventure, right? Everybody, some of you might have started with X, done the triangle right away, right? So it's up to you. Okay. Now you have to start, this is probably, well, I know you've seen parallel lines and talked about parallel lines before, even in the linear equations unit last year. But we're going to give it a different approach here. So parallel and transversal lines, right? So parallel lines are two or more lines are considered parallel if they never meet or intersect. You can recognize parallel lines when the symbol in the form of an arrowhead is visible on two or more lines, right? So for example, if you see the arrowheads matching here, this line would be considered parallel to that line. So what we would say in terms of notation, watch this carefully, segment AB, right? So from A to B would be parallel to CD. That's what we would say if you say that. So basically, what it's saying is segment AB is parallel to CD. Okay. Notice that also, if you see the other two arrowheads, right? Like there's two arrowheads here matching the two arrowheads in there. That tells you that those two segments here are parallel as well. So EF is parallel to GH. So there you go. That's what we call parallel lines. You could have more than two, but for now we're just gonna stick with two. And then you have something that we call a transversal, a line that intersects two or more lines at distinct points. Note, a transversal line can also be a parallel line to another line. Let's highlight that part because it's going to come back. It actually already happened. I just didn't highlight that. When a line is referred to as a transversal, we know that along it, we can find four distinct pairs of angles. I'm going to use a different highlighter for that, but I would highlight this with a different color. When a line is known to be a transversal, there are four distinct pairs of angles found along that transversal. So in this case, guys, we would consider this our transversal here. Okay. And quite often, I will put like a T there. So what is a transversal, Mr. Erickson? It's a line that cuts through two or more lines. That's what a transversal is. So a little bit of information overload today. I apologize. But let's go back here just real quick. So Mr. Dirksen, this line right here crosses through two other lines. Would this be a transversal? Yes. Would this be a transversal? Well, let's see. Does it cut through two or more lines? Okay, it is. Is it? Let's come from this side. This line crosses through two or more lines. Is that a transversal? Yes. Yes. Right? But they also happen to be parallel to each other. So it's kind of like a full package right there. Anybody want to guess what shape is formed inside here? A parallelogram. Parallelogram is a slanted square, right? Or a slanted rectangle. Okay, let's keep going. So these four pairs, I need you to have to know them, and to maybe you need to add that to your study sheet. Strongly suggest you do that. These are the four distinct pairs that I'm talking about. Okay, four distinct pairs along the transversal. So I'm going to highlight the transversal just on the line. I'm going to say, hey, this is the transversal that we're focusing on. And I know this is not very common, but I put numbers for the angles that are formed. Notice that there are four angles right here, and there are another four angles right there. Okay, so along this transversal, we have the first pair that we call corresponding angles, and I'll highlight this for you. I'm going to use orange. We would say that if you stay on the left side of this transversal, we would say that this one and this one would be corresponding. Okay, guys? Those two would be corresponding. And I want to be a bit more, I'm going to give you another set of corresponding angles. And I'm going to say that 4 is corresponding to 8. 4 is corresponding to 8. So I will say that if this is your transversal, it cuts through two lines. This space that's occupied between the two lines is called interior. This is the interior space. And therefore, everything outside the lines is exterior. And so below here is also exterior. So you need to know that, like when we're following the transversal and we're considering the two lines that have been cut by it, the space in between is interior. So everything outside of it, either below or above, is exterior. So I will give you the technical definition of corresponding angles. Here you go. Found on the same side of transversal. I'm just going to go T here. One is interior, the other exterior. Hope you can read that. Let me zoom into that box. Focus. There we go. That's much better. Okay, so let's test this. Found on the same side of the transversal. So if you think about it, this is my transversal. If I just focus on this side, one is exterior, one is interior. One is interior here and one is exterior, right? So this is a pair of corresponding, and the orange is a pair of corresponding. What about on the other side, guys? Like if we were to go on this side, 2 would correspond to 6, and 3 would correspond to 7. I'm just not going to highlight them all. I'm just going to tell you this. There are so angle 1 and angle 5, angle 4, and angle 8. So those are the ones I already highlighted. And then as well, angle 2 and angle 6, angle 3, and angle 7. You probably can't wait to tell your friends about this lesson, right? I know. You can text them later. But these are your corresponding angles, okay? Corresponding, they're on the same side of the transversal. One is interior, one is exterior, okay? Let's go to the next one. So there are 4 pairs along the transversal, 4 distinct categories. So this is the first category, right? And then we go to this one here. Alternate interior, which is very closely linked to alternate exterior, which we're going to do in a bit. So let's just again say, hey, this is interior here. This space here is the interior space, and we're just going to focus on that. This is a little easier. We would say that 4 and 6 would be alternate interior, and therefore 3 and 5 would be alternate interior as well. Okay, so there are two pairs. Opposite side of transversal, both interior, not adjacent. Say what? What does adjacent mean? Adjacent means they're right next to each other, but they're not, right? These are not right next to each other. Like 3 and 4 are adjacent, but 4 and 6 aren't. So it's like a crisscross. Let's make that little X here. So alternate means on opposite side of the transversal, and interior means they both have to be inside, but not adjacent. Right? My head is spinning, Mr. Erickson. Thank you for that. I need a Tylenol now, right? 4 and 6, as well as 3 and 5. So not as many options as we had with corresponding. There we go. And later on, I'm going to give you the shortcut for each one of these. I don't want you to write out in alternate interior angles all the time. Next, let's do the alternate exterior. So exterior, right? So this is focused on exterior. That's why I'm not worrying about the interior here. Same thing here. Alternate exterior simply means, right, that this one would be alternate exterior to that one, and that 2 would be alternate exterior to that one. Okay, 2 and 8, 1 and 7. So I'll just say this. Opposite side of transversal, both exterior, not adjacent. So angle, sorry, what was that? Angle 1 is alternate exterior to angle 7, and angle 2 is alternate exterior to angle 8. You're like, what? Why are you spending so much time on this? Because this is literally what a lot of this unit is going to revolve around. So get familiar with them, know where to find them. Okay? If you know where to find them, life is going to be a lot easier for you. I promise you that. Actually, just math is going to be easier. Life, I'm not sure about that. Consecutive interior. The last category, these are called CIAs. Okay? CIAs. They are, I'm just going to make it short and sweet. It's basically this one and this one, as well as this one and this one. So these are CIAs, and these ones are CIAs. Think of consecutive. Consecutive means like one after the other. So consecutive interior, they're both on the inside angles, right? So these two and these two. So they're not crossing the, so 4 and angle 5, as well as angle 3 and angle 6. Okay. Careful here. It's a bit of a mix, right? Corresponding, they were on the same side of the transversal, right? The very first one we did, but one had to be inside, one had to be outside, right? Alternate interior, they also were on the inside, but they were kind of like crisscross, right? This one is just, they're both on the same side, right? One after the other, like that. So these are the 4 that I need you to, that'll be basically your homework to make sure you somehow transfer this onto your study sheet. How would I do that if I were you? I would probably, I'll give you just a hint. I would probably do one of these. I would have this like that, and then just go 1, 2, 3, 4, 5, 6, 7, 8, just like I did. And then maybe just tell yourself, right, corresponding, just have one example, 1 and 5, angle 1 and angle 5. And then maybe highlight it accordingly so that it sticks out. And then you would have alternate interior. Alternate interior would be 3 and 6, for example, or 4 and 5. So you just go 3 and angle 6, for example. And alternate exterior, you say 1 and 8. And then consecutive interior, CIAs, would be 3 and 5. And I have different numbers, I think, than the one I give you in the notes. That doesn't really matter, right? But just have one like this in a small section of your, and you can make it like, this is just for me. You can make it prettier. You can add highlights or whatever. I'm not talking about hair, right? Just highlight that. But whatever works for you. Watch this. These are pairs. Okay, these four angle pairs are always found along the transversal. Always. Every single transversal that cuts through 2 or more lines, you will find these 4 categories in there. Okay, always. Okay. Whew. I'm wondering if I leave this part for tomorrow. I think so. I think your brains are too much, there's too much theory already. So you just gotta trust me for now. Come with me. Keep coming with me. Is that gonna work? It's not gonna work if I skip that. It's gonna hurt our cause. So I was thinking maybe, but sorry guys. How about this? I go through this page and then I'll do 1 or 2 examples. That'll be it for today. Okay. So please stay with me though, because this is important. Okay. Angles formed by parallel lines. Okay. So now we're focusing our attention back to parallel lines. Conjectures. And I will summarize this in a bit. This is what it's saying. When a transversal intersects lines that are parallel, then all of the following are true. Okay? Alternate exterior angles are congruent. Alternate interior angles are congruent. Corresponding angles are congruent. Watch this. Congruent, congruent, congruent. But what does it say about the CIAs, consecutive interior angles? They are supplementary. So if you see that lines are parallel and you find these angles, these 4 categories, then this will be true. All of these will be true. Okay? So I will summarize that. If lines are parallel, right? The lines that are cut by that transversal that you're going to follow are parallel. Then all of these are true. All of these are true. Okay. I'll summarize that because so the first one is alternate exterior angles are congruent. Same with alternate interior angles. Same with corresponding angles. I will just go corresponding like that. Angles are congruent. But the CIA's consecutive interior angles are what? They're going to be equal to 180 degrees. Okay, so this is the first part of the theorem. If parallel, then all of these four are true, guys. All of them. Am I going to need all of them every time? No, but you just know that this is true. On the other hand, if you were able to show that one of these is true, like if you can show that you pick, hey, I'm going to see if alternate exterior angles are congruent here in this diagram, then you could automatically say, well, then all of these things are going to be true and lines are parallel. Okay, so if you can show that one of the following is true, then alternate exterior angles are congruent, right? Or you can show that alternate interior angles are congruent, or corresponding angles are congruent, or you can show that consecutive interior angles are supplementary. If you can show any one of this, if you can do a check mark on any one of these, then you can conclude that lines that are connected by the transversal are indeed parallel. So it's going the other way, right? So basically it's asking, are lines parallel? Question mark. Show one of the following. Following is just FF. You need to show, hey, AIs, are they congruent? Alternate exterior angles, are they congruent? Corresponding angles, are they congruent? So can you show that somehow? Or can you show that the CIAs add up to 180 degrees? Like, can you put a check mark on one of them? If yes, to any of the above, we say lines are parallel. So it's going, we're going to use this interchangeably. Sometimes we're going to use this property to show whether or not lines are parallel, and other times we're just going to we're going to use it to figure out what the missing angle is. Okay, mystery angle kind of scenario. Dun, 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 dun. We're almost done. So here, I used GeoGebra for this. GeoGebra draws everything to scale, exactly the way it's supposed to be. So I didn't make this up. Okay, this is drawn to scale. How many transversals are there? This one cuts through two or more lines. This one cuts through two or more lines. This one does. This one. So they're all transversal, Mr. Dirksen. How is this helpful? Let's just focus on one at a time. Let's call this transversal 1, and let's call this transversal 2. We're just going to focus on those two transversals. We're going to travel along them. So use a highlighter. I'm going to say, hey, let's travel along this transversal and see what happens. What can we determine? I'm going to use orange to find two corresponding angles. Ready? This is my transversal. If I say, hey, let's consider this angle right here. Okay. What would that angle correspond to? Which angle would this one correspond to? Remember, they're on the same side of the transversal. One is outside, exterior. One is interior, right? Those are corresponding angles. So corresponding angles. That's and I'm just going to say, boom. Are they the same? Are they congruent? We know the name. We figured out the name. Are they indeed the same? Yes, they are. You know what you could now say with 100% certainty? You could tell me now that this line and this line, they're parallel. Done. End of discussion. You were done. I could have blocked all the other ones off. If you could just show that this is 118, this is 118, these two lines are indeed parallel. But let's examine the other ones. What would these two be called in this scenario? Alternate, this one here. This one is alternate interior to this one here. So I found my alternate interior angle. I found them. Are they also congruent? Yeah, they're both 62, Mr. Jackson. What are you trying to do here? Don't try to like confuse me here. But yeah, they're congruent. So we know the name and we also see that they're congruent. So hey, it's checking out, right? I found that one of them was true, but I'm actually finding out that all the other ones turn out to be true as well. What about alternate exterior? We need to find alternate exterior angles. I'm running out of highlighters. Pink. I'm going to use pink. I don't want to use, okay, I'm just going to show you guys. 118 is alternate exterior to this one out here as well. But I already used 118 here, so it's going to get too messy. So I'm just going to say that, and I think you would follow, right? This one right here, this angle right here is alternate exterior to this one down here. These one are alternate exterior. So that's the highlighter I'm going to use there. Are they congruent? Are they 62, 62? Yes, they are. Bingo, right? So it turns out that all of them are true. I still need to do one more check. Would the CIAs add up to 180? And I'm running out of highlighters. So these two would be considered CIAs here. Same with these two. This is a CIA. CIAs. Consecutive interior angles. Do they add up to 180? We know the name, and now we know they add up to 180, right? Ka-ching, right? So we started off with just looking at corresponding angles. We determined, hey, they're congruent. What about the other ones? Because technically the story ends here. I can confidently say these two are parallel. I could do this. Use my red pen. I could say this. This line is parallel to this line. They will never meet. You've basically determined that this circle here is a copy of that circle up there. They're copies. So if they're copies, that means that, right, these two lines are the same. It's a copy line. Like they just took this line, put it there. These will never meet. But we use these four angle categories to determine that as well. Okay. Normally, I would do the same thing on this side. I would say, look at alternate exterior. They're the same. alternate interior, right? No matter which one you take, if you take these two or those two, they're the same. Do consecutive interior angles add up to 180? Yeah. So I already determined that this is true, but if I were to cut this with another transversal and another one and another one and another one, I should come up with the same conclusion that these two lines are parallel. Because once they're parallel, it doesn't change. One more thing, do you see a quadrilateral in here? You see that? What should all these four angles add up to? 360. That's right. And they do add up to 360 because these are 180. These two are 180 as well. 180, 180 is 360. If you had a triangle formed in here, that triangle, inside the triangle would add up to 180. So we're going to mix it all together. And I'm just going to stop here because I can tell you're... what is for homework? I would say just make sure your study sheet has those four categories of angles and know how to find them and to identify them. That's all. On your study sheet or memorize them, whatever works for you. Thank you guys. You were great.